Okay, so today we're going to be talking about choosing a factoring method and also making sure that something is fully factored. So if I look at example A here, I've got 2x times x squared plus 4. So if I look at just the x squared plus 4, is there any GCF that can come out of there? Okay, and it's not the difference of squares, right? It's actually two squares added together, so there's no way to factor that. So that particular example would be considered fully factored. Now if I look at the next one, I've got 2x plus 6 times x plus 5. Initially it looks like, well, it's already been factored, right? But if you take a look here inside the parentheses, is there something that I can factor out of 2x and the 6? Yeah, they have a GCF of 2. So I can actually take a 2 out, and I'm left with x plus 3. Oops. And then, of course, we still have the x plus 5. So in order for that expression to be fully factored, I would have to take that greatest common factor out. So that what I highlighted would then be the final answer, yeah. All right, and then here I've got 2n times n squared plus 4n minus 21. Well, what I need to figure out is, can I factor that trinomial that's inside of it there? Is this factorable? So that would be the next thing I would check. So if I want to get n squared, what times what gives me n squared? Just n times n, right? Okay, and how can I get a negative 21? What times what equals 21? 7 and 3. Okay, so if I check the inside and the outside, all right, what do I need? Does one of those have to be negative? The 3 should be negative for it to equal a positive 4n, right? So I've made negative 3 and a positive 7. So then that would be the final factored form, fully factored form of that expression. Okay? Any questions so far? Right. If it's not fully factored, then you have to continue factoring it until it is. Okay. All right. So let's take a look and do a couple on whiteboards and see what you guys think here. All right, so most of you are noticing that there is the GCF here of 4, right? And so you get x plus 1, and then if I take out the 4, we have x plus 1 again. Well, normally you're going to put your number out in front. So I'm going to put the number out front. And if I have x plus 1 times x plus 1, how else could I write that? X plus 1 and then that quantity squared, yeah. Okay? So that would be the answer to that one. Let's try another one on your whiteboards. Okay, so I can factor what's inside, or I should at least see if I can. To get x squared, it's x times x. How can I get 3? What times what is 3? There's only one way, right? 3 and 1. Okay, so if I check the inside and the outside, I want them to have a difference of negative 2. Which one has to be negative? The 3 has to be negative, and that's positive. So 5x times x minus 3 times x plus 1 would be your final answer. All right. All right, what do you guys think about that one? Okay, so it's just x minus 1. Is there anything that I can factor out? No, so that one is already fully factored. All right, so basically when you guys are given an expression, they're not going to tell you anymore how it needs to be factored, whether it's grouping, whether it's GCF, whether it's just a regular trinomial or a special product. So you're going to have to run through a series of steps as you're factoring those polynomials. So the first thing you want to do is look for a GCF. Look for that greatest common factor and get that out first. So that'll help, like some of the problems will have large numbers on them, but as soon as you divide out the greatest common factor, then the numbers are much more manageable. So you want to always look for a GCF at the start rather than waiting until you're done factoring and then see, oh, whoops, there's a GCF there. So do that at the start. Then the next thing you're going to do is you're going to look for special products. Because if it's a special product, you can just use the pattern to factor it. So by special products means, is it a perfect square trinomial? Or is it the difference of squares? Okay, so look for your special products next. Then, if it's not a special product, you just go about factoring it the way we've been doing it with our guess and check method. And then finally, look to see if there are common factors. And so what I mean by that is, suppose you have x plus 2 times x plus 2, you can just rewrite that as x plus 2, the quantity squared. Okay, so those are the 4 steps you're going to go through when you're looking at an expression. You're going to see if there's a GCF. You're going to look for special products. Then if it's not a special product, you're just going to factor it the way we've been doing. And then you look for common factors. Okay, so I've got an example here. Negative 2xy squared plus 16xy minus 32x. So first of all, I'm going to look for a GCF. Well, right off the bat, I see that my leading term is negative. Do I like having a negative out in front? No, I don't. So I'm definitely going to take out a negative. Is there a number that goes into 2, 16, and 32? 2 does. And then what about, are there any x's or y's that I can take out? I can take one of the x's out. So now if I take out the negative 2x, I'm left with y squared minus 8y and then plus 16. All right, then the next thing I look for, is it a special product? So let's take a look inside of there. Do you guys remember how to figure out if it was a perfect square trinomial? We looked at the start and the finish. Are those perfect squares? All right, so then we should test it out and see. I'm going to leave the negative 2x out there because that's part of the answer. So let's see if y minus 4 times y minus 4 works. I get negative 4y and negative 4y. Does that add up to my negative 8y? Yes, it does. So then I can rewrite it, again with the negative 2x still out in front, and then y minus 4, the quantity squared. Okay, any questions there? All right, then on your whiteboards, you're going to have 3x squared minus 18x plus 27. So first look for a GCF, and then see if you can factor what's left over. All right, looks like most of you guys are getting it. So we have 3 for our common factor, and then we're left with x squared minus 6x plus 9. And then you guys tested it, x minus 3 times x minus 3, and it worked, right? So you ended up with 3 times x minus 3, the quantity squared. All right, let's take a look at this one. Do I have a GCF? Yes, I do. What's my GCF? 2y. So I take out a 2y. Now I'm left with, let's see here, x squared minus y squared, right? So do I have a special product there inside the parentheses? What do you think? Yes or no? Is that one of our special products? Is it either a perfect square trinomial or the difference of squares? Is x squared a perfect square? Is y squared a perfect square? Am I taking the difference? So I have the difference of squares, don't I? Okay, so if I say different squares, what do you, a difference of squares, what do you say? Different signs. So we're going to have x plus y and x minus y. Okay. All right, so I'm going to have, nope, not that one. I'm going to write one for you guys on your whiteboards. Okay, is 4x to the 4th and 9 perfect squares? And we're taking the difference, so it's another difference of squares, right? So what's the square root of 4x to the 4th? 2x squared. So that's what the first term is. And the square root of 9? 3. And if I say difference of squares, you say different signs. Okay, one more example here. All right, so now if I look at this one, I can see that I have a GCF of 3x squared. So I'm going to factor out the 3x squared. And then I have x squared minus 5x plus 4. All right, so how can I get 4? Does it look like this one's a perfect square? It could be, but then if I do x minus 2 times x minus 2, I'm not going to get what I want in the middle, am I? I'm only going to get negative 4x. So this one's just one that you factor normally. They're both going to be negative because they're multiplying to a positive. So what's the other way that I can get 4? Besides 2 and 2. 4 and 1, yeah. And if I check it, sure enough, it works out, and so that's your answer. Okay, so sometimes it'll just be one that can be factored the way we've been doing them all along. All right, so what is the very first thing we're always going to look for? Everybody, one more time. GCF. What's the second thing we're going to look for? Special products, either a perfect square trinomial or a difference of squares. All right, that's what I have for you guys today.